I'm Daniel Livingston. I'm the Programme Leader here at the Digital Design Studio. So it's my pleasure to welcome you. Also my pleasure to introduce you to Andreas Stiegler, who is actually a PhD student of mine on a completely different topic. But today he's here, he's going to talk about gamification and accessibility. So without further ado, Andreas.
So, hey all. I'm Andreas Stiegler from the HdM Stuttgart, and as everybody noticed by now probably, I'm not a native speaker. The HdM is actually down here in the south of Germany, in Stuttgart. And I started my PhD on game AI, so artificial intelligence, at the UWS. That's how I met Daniel. He was my supervisor back there before he went over to the Glasgow School of Arts. That's not what we'll talk about today. As for my job, I'm actually a researcher in some accessibility projects, and there I'm mostly responsible for, well, you guess, machine learning AI stuff. That's synergy with my PhD things, and I'm also responsible for the gamification. As I have a game development background, so I spend a bit of time in the industry, and game development is all over my life as a hobby, and I'm giving classes in game development at the HdM. So, enough of the boring Andy, let's talk a bit more about gamification and accessibility. So we will actually talk about today a lot about gamification, not so much about accessibility. I just want to introduce a few fundamentals. First questions, perhaps, what's your background? So in what topics are you? Do you already know what gamification is in principle? Okay, good, then we will just quickly do it. Do you know what accessibility is? Okay, good. So, just the very basics of accessibility. What we do is we have a bunch of research projects where we are building infrastructure that allows you to transfer your preferences, your settings from one device to another. That's the basic idea. So, like, I have my smartphone adapted in a way that I can actually use it. If you have certain impairments, like visual impairments, you will have like a larger zoom or something like that. And if you switch over to a Windows PC or so, the PC automatically adapts to bring the device at least in the domain that you can access it. That's a big difference between accessibility and usability. Accessibility is being able to interact with the device at all, and usability is then designing this interaction in a way that it is as smooth and as convenient as possible. So that's the accessibility thing. Now what we are doing there is we are creating documentation for developers. So one of the projects that's what we will talk about today that we do is focused on getting software developers to support some fundamentals, or to at least teach them about accessibility. There's a big problem there is that you could solve some of the accessibility problems from a technical point of view rather easily, but the developers don't understand that. At least in my school, for example, we didn't teach a lot about accessibility before the research project started. So a lot of software developers out there working in the industry don't really know about accessibility. And that's not just the higher management levels who come up with some corporate identity designs and so to break everything, things like that, but also the low-level software developer. Typical thing is if you want, that's a nice example perhaps, if you want to have an interface, a user interface, say a web page for example, adapt to you, then you have to express the web page in some kind of abstract way, the layouting. That's HTML for example. HTML is some kind of abstract representation of a user interface. You are just giving a semantic structure there in the HTML. If you do it well, you can screw HTML up in whatever way possible, but if you do it correctly, then you have some semantic and layout representation in the HTML. And then you have a CSS file, the style file, that then tells you how this stuff looks. And to support accessibility, you just have to alter this style file to like increase font size or so. That's an abstract user interface, yet that's not how software like Windows programs or so look like. They are really written in a way, I want this button with 20 pixels from the left and 10 pixels from the right, and it has to be telecom pink or something like that. So with corporate identity stuff all over the place. And we are trying to teach the software developers some fundamentals to get them more into using more abstract representations of the user interfaces and support those fundamentals. To do that, we deploy gamification. As always, if you want to get people to do something, everybody plays games, so it might be a good idea to actually use gamification there. Yet we have a problem. If we want to teach developers about accessibility and we want to deploy gamification, we have to be accessible ourselves, right? We can't say, hey, please everybody do something for accessibility, but we aren't accessible ourselves. So our platform where we support and document the things has to be accessible too. So we have to combine gamification with accessibility. And at first glance, that sounds rather trivial. If you look a bit closer, it's actually quite a problem. If you just imagine, say a screen reader, so you're blind, and if you're blind, or you have very strong visual impairments, you might favor using a screen reader. A screen reader is basically just a small program that runs over a web page, for example, and reads it to you. So it's just like your mother reading the book to you. It's in incredible speeds, by the way. There's people, I have a colleague who's blind, and the screen reader works in such a high speed, I can't understand the word, even in German. So that's completely, your brain gets very trained to that if you use it constantly. So the problem there is that what you're doing now, you're mapping a two-dimensional representation of information, a web page. It's a two-dimensional thing, right? Imagine YouTube, you have your main screen where your video runs, and a sidebar, for example. And for us, just from looking at it, without having any further information, our brain immediately does some visual separation of information and immediately identifies, that's the main screen where most of the stuff happens, and this small sidebar, also there's a lot more information. Information density is actually a lot higher in the sidebar, yet our brain immediately identifies, that's just side information that we can look at if we want to see related cat videos or something like that. And that's a problem. As what a screen reader is now. A screen reader is a one-dimensional representation. It's reading. So it's just, you can start somewhere, but you can't read something and then in parallel read the sidebar or something like that. You can't do that. So you now are mapping a two-dimensional representation of information on a one-dimensional one, and that's actually tricky. As you now have to have additional semantic information in there. As our programs aren't that good enough, that's actually a synergy with my AI topic. With AI you could do this visual representation and visual separation, like representing the main panel separately from the side panel. You could do that with AI. There are clustering algorithms and visual separation algorithms and all those things. So with image processing you can get to that. But a typical screen reader doesn't do that. So the screen reader relies on having more semantic information in the web page. So in the web page there has to be somewhere that this sidebar is actually a sidebar. So that the screen reader knows, okay, they have certain ways of navigating. If the user presses the sidebar button, then he actually wants to get the sidebar. Does that make sense so far? Good. That is just the basics, what the difficulty between gamification and accessibility is. Now another difficulty is, or a fundamental of gamification perhaps, is that gamification should always be optional. So you should never be forced to use gamification. As soon as you are forced to use gamification to solve a certain problem, it's no longer gamification. Because then you are, I mean, the idea of gamification is to use some concepts from games, so things that make us do very repetitive tasks in games, like farming for a better sword, or running for higher scores, and all those things. We are doing very repetitive tasks in games, and yet they somehow seem to be fun. We are also doing very repetitive tasks in our job, like filling out timesheets or layouting applications in a certain way that an accessibility program can deal with them. It's also very repetitive, but somehow it's not fun. And gamification is the idea of identifying elements that are unique in games and transferring them over to non-game scenarios. So that's the idea of gamification. Now, when you combine it with accessibility, you have to pay attention that gamification is a big buzzword. So a lot of people are using it. The industry is very interested in that, as you can actually show that it increases productivity. There are some studies that it's not an increase in productivity in every case. There are some cases where it's not that good, especially if you have security relevant subsections, then you should probably not use gamification there. But in general, for the industry, you have a process, and that's your money-making process. That's whatever you have to do, and you are putting gamification on top of that process to increase productivity or just to have your people do it in a more convenient or in a more effective way. That's your idea. That's why you, as an industry man, are deploying gamification. Now, you don't want to build this gamification as a must-have into your money-making process. You still want to have your money-making process as efficient as possible, because that's what you do, make your money with, right? Make sense? So that's gamification always has to be optional. It's always something that you have separately. If you don't want to use gamification today because you're just fed up with it, you should always be able to use your normal processes. So you always have to have it separately. Now, that comes with a number of interesting questions. I'm still talking, I'm even on the first slide. But we'll get to that. that comes with a number of interesting problems. Like a lot of gamification that's used currently in the industry and that studies care about has to deal with visual representation, like badges, for example. Or like getting a different color in your username in a forum if you have a certain karma level or whatever. You know those things from the internet, that's everywhere. Or Stack Overflow, if some of you do programming, that's a platform where people ask about programming questions and other people answer, and people actually can vote how much they liked or how much helpful the answer was. And the most helpful answer is then on top, that's some kind of self-organization, but it gets a different color and it's on top. It's also gamification. And all those color things and those arrangement things, they don't really work if you combine them with accessibility. As obviously you can't rely on visual representation, right? Just if we mention the blind user, then we obviously can't rely on visual representation. So what we need is, we need forms of gamification that are independent from the actual representation. Clear? Is that all clear so far? Good, because that's where we start. Now what we did there in the research project is, first of course we went through all the research and, well, through all the research, but through a lot of patterns and approaches that you have in gamification already, and tried to port them and combine them with accessibility. This was very unsatisfactory, as a lot of those approaches really relied on some kind of representation. So what we did then again is, we have a bunch of people who come actually from the games industry, so we thought, hey, why not do it different? Just let's go one step back from the actual gamification and look at real games again. So we're looking at real commercial games, and we have tried successful games that are fun. That was a good idea, so we could just select our favorite games, for example, take a look at them and try to find out what is it that makes them fun. Of course, we are not the first guys who do that. There's a lot of research about that. So we are just looking at the patterns of what is fun. There's a lot of psychology research on that. There's a big... at that point, is somebody here that's actually into psychology or so? With a game and play and...
Yeah.
Yeah? Okay, so there is this big separation between play and game. So play is this one generous thing, like... Yeah, like when I'm later on the airport, I'll probably play around with a Coke bottle or so, just because I'm bored. That's play. Game is this, or playing a game is this structured thing. So you are planning to play a game. We're talking about games here. Right, so anything more I have to say before we start? I think that's it. So what we did is, we went one step back. We are looking at real games and trying to extract what makes them fun. And that's actually what I want to do with you today. We will take a look at a few game examples and then explain a bit those fundamental concepts of what makes things fun. And those are also the fundamental concepts of the, say, normal gamification that you read everywhere. It's just that they are already combined and pre-baked in some case with certain representation methods that are very successful to represent this type of fun mechanism, put it that way. But we need to have the pure fun mechanism here, because we want to have this representation thing be unique per user, so that every user has its own representation for it. Okay, so let's start. Let's start with this game. The titles get more recent the farther we get in the presentation. So which game could it be? Tetris. Yeah, perfect. So, what makes Tetris fun? It cost me quite some years of my house, I guess. What makes this game fun? Well, the first thing that probably immediately is obvious if you compare it to your job, for example, is that you have... Or what's the first thing that you notice? I guess it's the reward. So we actually get reward in some kind. So once I place this block in a right fashion and all my lines are aligned, they start blinking in an incredibly impressive animation. They vanish and I get some points. Even better, I even have 2 stages of reward instead of just getting some points that depend on how many lines I kill at once. I think every 10 lines or so that I raise, I even climb that level and the blocks come down faster. That's very interesting. Reward in general is also awarded in real life. At least at the end of the month, or the beginning of the month probably, if you are on a job. Yet there is a big difference. What we're talking about is immediate reward. So when I do the action, and if the action is successful, I get an immediate reward. That's interesting. As in real life, so in our job, we typically have reward or penalties. You can discuss if reward or penalties better, but we're just talking about rewards here, but it's more or less the same for penalty. When we have a real life, we typically have a very large distance between the action and the associated reward or penalty. Like driving too fast in Germany, for example, takes then 2 months until you get your penalty for that. And then in your brain is no longer really able to associate the penalty with the action that caused it. So, oh, I was really on the street that day. Oh, interesting. So that completely breaks the reward and penalty cycle. In games, we typically have immediate reward. Even better, we have even immediate measurable reward. That's also interesting. We really have a measurable reward here in a number, in a level, so it's really something that we can measure and compare. That's also not really happening in real life. But okay, if you're driving too fast, the money becomes, the high score climbs up too, but until you can no longer drive, because your car vanished. The typically rewards that we have in real life are not really measurable, as they are associated with a lot of context. And that's not happening in games typically. In games you really have hard and measurable reward. So what else is interesting in Tetris compared to real life? Alright, the action space. That's also something interesting. What do we know about the action space of the game? The action space is how many actions can I do at a certain point of time. Now the interesting thing is in Tetris that we know the complete action space. First, the action space is rather limited. We only can do very few actions at a given point of time. We can rotate the blocks clockwise and counterclockwise, always the active block. Then we can move them left and right, and I think that's it. Oh no, we can accelerate them down if we are really confident. So that's all the actions that we have. This is of course a very small set of actions compared with real life. Even filling out the timesheets that I have to do when I'm back at home next week. That's when you miss an internal meeting, then you assign all the nasty work to you, correct? So I have to fill out timesheets next week, and just filling out those timesheets has an incredibly higher dimension of your access, your action space than Tetris, right? You can do a lot more things. And that's difficult, as our brain seems to be our brain seems to love situations where we have a relatively small action space, so we can predict the outcome of each action better. Even worse, and I think that's the more fundamental problem there, in Tetris we know that the stuff that we are presented with is the complete action space. We know that there are no other actions, right? We know that this is everything except perhaps a developer hit something somewhere, but in general we know that this is the complete action space, and that's typically what they present you in games. They might increase the action space over time if you get like new spells or new abilities or so throughout the storyline or so of a game. So the action space in more complex games might increase with time, but they always try to represent you the whole action space, so that you are confident that you know every action that you could do. And that's very important, because that's something that you never have in real life. As our real life is so rich with context and intervened relations and whatever, you never have the complete action space. Or even if you have, you don't know that you have the complete action space. So the brain always thinks there could be something better. Good example is buying a laptop. If you want to buy a new laptop and you're running through the internet and searching for different models, and that might be better, but that has more CPU power and that has a better graphic card, and in the end you can only be disappointed. Whatever model you buy, in the end you are disappointed. As you always think there could be something better, as you definitely know you didn't measure and view the whole action space, because there are just so many models out there. So in the end of the day, you're always disappointed, because your brain always thinks, okay, there could be a better one. That's one of those abilities that we are always very good at imagining a different outcome. So we always say, okay, I'm instantiating Andy now in a different scenario, seeing what he does there, then the leading man, okay, that's a certain outcome. And that's what our brain constantly does. We are constantly imagining new situations. So I think that's all about Tetris when it comes to fun. So what do we have? Immediate reward, measurable reward, limited action space, and fully observable action space. So I think those are 4 basic gamification patterns. Okay, let's jump a few years. Which game could that be? Oh, if it fails now, then we have to help it. Daniel knows it.
Right.
No, he doesn't? Yeah, perfect, Diablo, right. So that's Diablo. What's Diablo? That's a hack and slay game. So you're running around with your hero, that's the sorceress down there, for example, and you are slaughtering demons and skeletons and whatever with large spells. The core principle of the game is that you gather better equipment as you play it. So the more you play it, you find better sorts of dragon slaying and magical rings with +7 armor or whatever. So you're gathering better equipment, you are increasing in level, you get new abilities and all those things. So in principle, it's a bit similar to Tetris. Tetris had a lot of repetitive actions, right? Tetris itself is relatively repetitive. Even more repetitive than a lot of the real world job tasks that we have to do that aren't fun at all. It has to be repetitive as it has only a very limited action space, so there have to be patterns sooner or later. But they don't have to be in theory, but in practice there actually are repetitive patterns. Now, we have a far higher action space in games like Diablo. We have a lot of spells that we can choose from. We can move freely in a 3D. Well, it's actually 2D, it just looks 3D, but we can move freely in an environment. In principle, the gameplay isn't too different from Tetris. We are still doing very repetitive tasks. Also, the repetitiveness is now at a different abstract level. Our sorcerers might begin every combat with freezing the enemy and then casting a powerful fireball at the enemy. That might be the initial action in every combat. And that's very repetitive. Also, the concrete example of how to cast the freeze and how to cast a fireball might be unique. So if you would have just recorded the user actions in Tetris, you would probably just from analyzing the user actions already see certain repetitive behavior. That's probably not working in Diablo. In Diablo you have to get on a bit of a higher semantic level to see the repetitiveness. Make sense? But in principle they are still repetitive. One thing is very new here compared to Tetris, and that's development. What we have here now is that our hero becomes stronger the longer we play, even across game sessions. So actions that I did in a previous game session affect my following game sessions. Like if I found a new ring of power that I have to throw in a volcano somewhere, then this ring of power stays. It stays through all the game actions until I drop it somewhere. So that's permanent development. That's interesting, as that's something that we obviously have in real life. If you messed up once, you messed up forever. So that's something that we obviously have in real life. It's not like restarting the whole world every time, like Tetris does. And that's very interesting. Especially here, as we have measurable development again. It's always this measurable popping up, and actually this ability to measure something and to compare something seems to be very valuable for our brain in order to have a certain feeling of satisfaction and for our brain to trigger its own reward mechanisms, showing some dopamine and whatever it does. So this measurable progress that we have over game sessions is very important. As we see here, our spell power increases, and we see that the levels of our spells increasing, and our sorcerers become more powerful. So we can really see and measure the progress that we do over game sessions. And we can never lose levels. It's also interesting. In whatever fantasy game or role-play game, there's no role-playing going on in Diablo or similar games, but they are still called role-play games for whatever reason. You never lost a level, right? You played games like that. You don't lose levels, you only gain them. So you only have reward, and that's accumulated over time, so you have to cross many game sessions. So that's very interesting there. Anything else that's important about Diablo? I think that's pretty much it for now. We might come back to it later. Yep, I think that's it. So jump to the next game. We're getting a bit more recent. Very famous first-person, it's not really a shooter, but it's a first-person puzzle game with physics. Yeah, Portal, perfect. I heard Portal somewhere. Yeah, right, correct. It's an educated audience. Right, so that's Portal. What is Portal? Portal is a 3D physics puzzle game. It's not really a shooter. What you do there is you're running through a storyline of some nasty AI that does evil experiments, and you have to trigger certain what's the English word? Push certain buttons in the correct order and place cubes. So it's physics puzzles. You have to make some nasty experiments with fluids, like letting them flow in another route that you can swim through. Typical physics puzzles. What's different here is it's not really repetitive. There are some actions that you do, but instead it involves very, I would say, very complex cognitive tasks. So you really have very cognitive, challenging puzzles there. You can really spend a while solving one of those puzzles. I would say even that they are even more challenging than a lot of stuff that you do in your job. So that's interesting. And still yet it makes a lot more fun than debugging a certain rendering function or something like that. It feels a lot more fun solving physics puzzles. So that's very interesting. What could be the cause? Well, first glance, of course, we have a lot of mechanisms. First, we have this immediate reward. So once we solve the puzzle, we actually poof, get the door open to the next puzzle, and we get a bling that we know we are on the next level and something like that. So we get an immediate reward. That's not happening. Well, it's somehow happening if you debug a render function. Once it actually works for the first time, you also get your reward. Also, it's awarded by Visual Studio instead of some game. Could be better. Well, we actually had, this was a nice side story, we had a nice experiment at a university where we combined some traffic lights with the SVN source control of a project, and whenever they submitted something, and there was a big screen, and whenever somebody submitted a certain state of the rendering system and it broke the test, then the traffic light went red. And if somebody actually managed to solve a problem that was caused by somebody else, he would get some points. And you had this high score wall, this high score screen, where the scores are awarded per week. So that people could actually see. And I saw grown-up researchers waiting for the break when the others go to lunch to commit their stuff and quickly try to fix the issues of other people so that they increase in high scores. If that's not working gamification, they did it in the break time, right? So that's really working gamification. So, but let's go back there. So we have cognitive complex tasks, we have immediate reward, we have measurable progress, we have progress over time as we know which level we are, and we can continue where we were. Another interesting point there is that we have a storyline. We had a bit of a storyline in Diablo 2, but it's not really what Diablo was about. Here we really have a storyline. We have, especially we have a very charismatic character. That's the evil AI. It's called GLaDOS. That's an evil AI with a very unique speech. It's a bit of an internet meme now. And that was always talking with you, and you always had this confrontation with this evil, somehow funny AI. So you really have a story that's been told. And that's interesting, as that's something that we have in many games, and I think that's something where the line between gamification, a serious game, and a real game starts to blur. As in most gamification scenarios, we don't have storylines. Really, at least we might have storylines, but the storylines are imposed by the money-making process, not by the gamification process. Yet there are some examples of stories and storylines in gamification, like you have a small assistant, hopefully not Clippy, from the older Microsoft projects, but that's more or less anti-gamification, so to speak, but it worked. It had the story of this evil Clippy always popping up when you were just about to do something. It was more brilliant than gamification, but it worked to a certain degree, so at least it did something that we all remembered of this long gun, so it worked somehow. But there are some experiments where you actually do something like that. So you have a character, like a bit of a Tamagotchi or something like that, and through gamifications, through your implemented functions or so, the Tamagotchi becomes better fed or whatever. Something like that. So there are some approaches to that, but the majority of gamification is not dealing with storylines. So I guess that's something where it blurs. But there's no real sharp corner between gamification, serious games, and real games. So typically you can separate real games and serious games and gamification, as real games typically don't have a real life outcome. They don't have, except of course us wasting time or us feeling better or whatever, but they have no real life outcome. There is no money making process involved. Whereas in serious games, that's tricky, because if you have serious games for training, then you also have no real money making process involved, but at least you have a real life goal that you want to train somebody. Like for example for accessibility, so that's a bit difficult. But it's, we can show that we shouldn't confuse games with gamification. That's one of the traps that we first ran in our research. That you shouldn't confuse games, real games, with gamification. There's one very good example, I guess, where you can see the fundamental difference in both of them. So that's those are two games. Which one is that? Yeah, perfect. And that one? No, that's not StarCraft, but it's the right genre. It's a real-time strategy game, not too popular. Was there something with S? Yes?
Visualization.
No, but also a good direction. It's actually a bit of, I would say, genre-wise, it's a bit of a mix between those two. It's Supreme Commander. It's not too popular. Still one of my favorite games. They're popular in game development. For game development guys, is they really use the physics simulation for everything, for every single missile. But yeah, that's technical stuff. So we have two applications here. One obviously not a game and one obviously a game. Okay, they have a completely different visual representation and they approach stuff in a different way, but they both involve repetitive things. Where you can immediately see that there is some fundamental difference between those two is if you would do the thought experiment of introducing the magical solve button. What is the magical solve button? The magical solve button is a button that's associated with whatever super sophisticated AI you have out there, whatever problem you encounter, you just click the solve button and it's solved. With no boundaries, you can solve everything. So having to fill out your timesheets, click the solve button, all done. Having to debug a rendering function, click the solve button, all done. So it can really solve everything. Now for an office application, that would be an amazing sales factor, right? You could really sell applications that solve everything. That would be quite impressive. It would probably be bought by Google pretty fast. For games, that would probably completely spoil the idea of the game. If you have a game where whatever problem or whatever challenge you encounter, you just click solve and it's done, then the games stop being fun. Actually, there are quite a bunch of games who went too easy through their patch processes. World of Warcraft is a good example, and they actually had big drops in user numbers. Is that clear? That may make sense to everybody. The solve button that solves every problem is not a real good idea for a game. That's because, I guess, the fundamental difference between games and gamification is challenge. For gamification, we have challenges, but the challenges are invoked by our money-making process. So there's challenges that we have to overcome. For games, it's challenges that we chose to overcome. So we ourselves chose that we want to overcome certain challenges by playing this game, either really with a real awareness or just subconsciously, but at least we chose to overcome them. For gamification or serious games, we have a money-making or learning or whatever process involved that makes us overcome those challenges. Make sense? So challenge is an important thing to think about. Good. So far to the few examples. We will have a few more examples right now. But what we are doing now is quickly running over pattern extraction. So what we did is we ran through a bunch of games in there and compared them to the gamification patterns. This is a bit what we did right now. Like we already extracted a bunch of patterns together: immediate reward, measurable reward, measurable development, all those things. And those are patterns. And all of those patterns, interestingly, were independent from their actual visual representation. Right? We never talked about how to represent something. We don't talk about how to represent reward. We just have to have it there and we have to have it immediate and measurable. Measurable perhaps not that important, but at least we have to have it immediate. Right? Make sense? Perfect. So here are a bunch of the patterns that we did. And when doing that, you notice something interesting, that similar patterns always appear in the same, say, layer of games. So you can typically, in game development, you typically structure a game into 4 or 5 layers. Say we have 4 layers, then on the very bottom layer you have the actual game engine. That's the code, the real programming code that runs the stuff. With a rendering system and a physics engine and an AI submodule and whatever you have. On top of that there is the content, the game content. That's typically the graphics of the game, the animation systems. And there's always the spiritual battle if like something like a storyline or dialogues is actually content, or if it is something for another layer that's a bit fuzzy, of course. But at least you have a certain layer with content if just for your visual representation or your audio representation. On top of that there are the game mechanics. The game mechanics are the rule set of the game. So more or less the laws of nature of our game universe. So there are hit points, there is damage, and if I damage somebody, it reduces their hit points, and if the hit points drop to 0, they die. That's the game mechanics of a game. There are certain weapon types, so certain damage types, and blah blah blah. On the very topmost level, there is gameplay or game design, and that's more or less the idea of your game. So what do you want to tell? Perhaps the storyline, so it's always a spiritual battle if storyline is something for gameplay or game design, or if storyline is something for content. There are a lot of good examples to support both opinions. So, on that level, you do the high level thing. Like, I want to have a game that's focused on, say, social relations. If you do an RPG, so say we want a game focused about social relations in a Lord of the Rings-like fantasy world, where the player is not a super mage, but rather a small hobbit, something like that. So that's the game design of the game, without really enforcing rules. And in game development, you always have the clash of titans between all those sections, as if the game designer at the top level wanted a game, say we have a first-person shooter, wanted a game where you can sniper over like 3 kilometers distance, and then the poor guy on the bottommost level doing the rendering system says, okay, so I'm supposed to render things that are up to 3 kilometers away. We won't do that. Okay, and then you have this feedback loop, then you have to change the game design. So they all intervene with each other in game development. That's always where you're battling. Okay, an interesting thing is that similar patterns always appear on similar layers in this game design. So we're not talking about the engine, so we can drop that. We're not talking about the real coding things here. We are more in design here in the moment. So that's a typical example for content, for certain patterns that appear in content. Anybody knows what game that is?
Mirror's Edge.
Ah, perfect. Right, so what we have here is, one step back first, Mirror's Edge is a parkouring game, basically, so you're running around a rather grayscale science fiction city with all the elements where you can make your cool parkouring stunts. All those elements that you can interact with are in this bright red. And that's interesting, because those are typical visual representation things that you use on the content level for game design, for navigating in 3D worlds. You have stuff like color coding in this example, or you have stuff like icons, so 3D icons, so to speak. So the big reward chest at the end of every dungeon that rewards you with the most treasure is always the same golden chest, so it always looks the same, so the players immediately know that's the room I have to head for. Stuff like that, so you have certain repetitive tasks. What else did I put here? Oh, exaggerated gestures, that's something very interesting. In games you typically have, and you might or might not have noticed that already, that characters in games often have very exaggerated gestures. They especially the breathing, it's always like, if you have like a first person, you're always standing like that, right? The whole time, and then try to do it just for 5 minutes. It's not what you do in real life. And that's something, I guess, interesting that often happens if you have games that are on a very photorealistic graphical level. So it's something that has not really to do with gamification, that has something to do with another interesting field when we talk about content, and that's the uncanny valley in graphics. Anybody heard about it already? Yep. So just very briefly, if you have a character, a human representation, and if your representation is very abstract, very far away, say a manga figure, for example, or a comic figure, or whatever, it's very far away from us, then it looks very sympathetic to us. We can immediately empathize with the figure. We associate emotions with it just from like having eyebrows drawn in a bit of a different way. So it works very well. The more photorealistic your model becomes, so you have now 3D faces and the faces look more and more realistic, the more and more empathic we are with the figure, until we reach a certain point where immediately it drops, and it not drops to like, oh, it's not that sympathetic anymore, it drops to like, ugly, disgusting. You can see that very good if you take a look at robot research. There's a Japanese professor who built a robot copy of himself that he can remote control. It's very amazing. But even so, it's very detailed. It's really a scanned face and everything is very detailed. It still looks incredibly disgusting. You immediately notice it. And that's interesting, as once we get closer and closer to real human representation, our brain at some certain point ticks and says, okay, the other thing that I just see is a human. But his eyes are moving correctly, and the skin has a somehow strange shading. What? Must be dead. And evolutionary, it was a good idea to stay away from dead people, as they are probably dead for a reason. So that's the uncanny valley. So at some point, just before, that's also if you take, like, I think in the past there was the hobby, or so to speak, to actually take photographs of dead people, to arrange them like in a sitting position or so and take photographs. And even just on the photos, they look disgusting. You notice, even just from photo, or even if it's still, because very subtle like motions or so, or positioning of arms or so is not there. And that's something that you do in games, that you exaggerate the gestures, like the breathing, typically, a lot, and those typical the movements, like, you know, they're completely exaggerated. But you do that to really tell every brain, hey, this thing is alive, by the way. Don't get disgusted. That's one of those things that content designers for games, and even for animations, have to deal with. So that's the problem there is that most of those panels that you find here are obviously representation dependent, as that's the layer in games that mostly is concerned with the representation, away from the technical layer, the game engine that of course tells what methods of representation you can use, like physics or so. But on this lower level we have a lot of visual representation. That's something that's not really useful for us. So let's step one level higher on the game mechanics. Now is the right turn to say the game title that we heard earlier. Yep, actually my key interest of research is a real-time strategy game, and yeah, it's more or less the stereotype of a real-time strategy game nowadays. Also one of the most successful esports titles that we have around. So a lot of Koreans playing it. But I always lose. What do we have here? Being an esport title, they spend a lot of thinking into setting up their game mechanics. Again, game mechanics are the rule set of the game. Like a bit like in chess, how can the figures move, and when do you win, when do you lose, that's game mechanics. And of course, if you have an esport game, those game mechanics, as StarCraft is a lot more complex than chess, it's a bit like chess, but you have a continuous space, so you're not just positioning figures on different tiles, you can position them everywhere. You have a lot larger map, you actually have terrain around it, you can gather resources, you can rebuild your figures when they are lost, and you do research to improve your figures. Oh, and your figures of course have hit points and damage values and ranged attacks and whatever. So that's more or less what a real-time strategy game is. So you see that it's a lot more complex like chess, but it still has some similarities. What you see there from carefully designed game mechanics for games, for successful games, you see that they talk a lot about challenge. Especially in those esport games. As in StarCraft, for example, you have 3 different races that you can choose from. You have those Space Marine, sorry?
I wouldn't get too detailed into...
Yeah, okay. So we have a lot of, we have different races and they all deploy different mechanics. So they have different challenges in their gameplay, but they still have to be fair. So that's interesting. So there are a lot of interesting methods on how to design challenge. That's something interesting. Is that something that we have this challenge, and in gamification the challenge is imposed from the money-making process or the teaching process or whatever you have below the gamification. But here are some ideas on how to design it. So how do you represent the challenge to people? And not represent in a way of visual representation, but how often do you impose challenges, for example, and how do you distribute them across people? Other interesting things is meaningful choices. That's also very interesting. That's a bit similar to the stuff that we extracted earlier with the action space. If you are featured with a bunch of choices and you think that all of those choices are somehow equal, your brain starts thinking about it, and then it's harder for you to actually fill a choice. Like if you have a choice at a certain point of time in a game where you just choose the color of a spell, but there's no other meaning, and you wonder, okay, is it really just for my pleasure so that I can pick my favorite colored fireball? Or are there later on monsters that are actually vulnerable to red spells or something like that? What happens there is that if you have choices that from your human position aren't meaningful, then your brain thinks about, but they have to be meaningful. I don't know the complete action space. There must be something involved in those decisions that I'm not seeing at the moment. So even if you know the whole action space, you can... a bad design can convince your brain that what you see is actually not the complete action space. So that's where you have to be very careful. When in flow, that's something for game design that's not too important here. Well, now the highest most level, one of the last slides, so we're heading to end. On the highest most level we have game design. Which game could it be? One of those many MMORPGs, so it's no fault if you don't know it. It's Wildstar. For a bit it looked like it could beat World of Warcraft. It didn't. What do we have here? On the highest most level in game design, people are trying to bring in game elements for the many different player types that we have. And one interesting there is, for example, discovery, like curiosity seems to be an important intrinsic motivation when we play games. So discovering virtual worlds, like everybody wants to run around a Lord of the Rings-like world, for example, or science fiction, opera, world, or whatever. So they are designing game elements specifically for people who like discovering. Like somewhere in a hidden cave there is a chest or a storyline hidden or so that you don't normally come across. You only get them if you're really curious and explore some dungeons. Things like that. They are also the layers where most of the stuff that we discovered earlier happens on game design, like designing reward and how to create feedback loops with players. So that's more or less it. The very last thing, so what did we do? We ended up with a whole bunch of those patterns, so all the things that we talked about. Each of those patterns then resulted in a bunch of like building blocks or pieces that can serve as tutorials for both us to implement it for our gamification problem, but they will also be available for the people using the platform, as of course other people might face the same problem, so they can also use it. Those could come in the form, of course, of some like tutorial, media, whatever. As we would love to represent all of them in code models that you can just use, but some of them, like the more abstract things, how you model a challenge or how you model gameplay, that's not really a coding problem, it's more a design problem, and you can't really have modules for design. We have already a bunch of them covered here with like some best practices approaches on APIs or so to cover that, but I guess a majority of the higher level ones will either be through some media tutorials or so, or then through documentation and templates on how to do that. And in the end, all of those building blocks, and those are all representation independent, they have then mostly automated. It's not working for everything, but we try to automate as much as we can, so that those building blocks are then automatically inferring certain representations. And the interesting thing there is that those representations, so everything that happens on the right, are now specific per user. So while you use gamification, you're always using gamification on a rather abstract level, with the concrete representation of your gamification being uniquely involved, derived for every user. Of course, we won't rearrange the buttons for every user in a random way or so, you will have certain patterns there. But if you need, or if you have certain preferences or certain needs for accessibility, then this can happen in this transformation there. And both of those steps probably deserve their own presentation, but I guess we get to an end. So I hope that I could give you a small overview on what perhaps the ideas, what makes games fun and how they are used in gamification and perhaps in serious games, and if that influences you and you think perhaps even a bit about accessibility, then I'm already happy. Okay, so any questions? And any code?
Yeah.
Yeah, go ahead.
You compared Excel before there to a video game. What makes you choose to play the video game for pleasure? You covered on psychology as well there. What makes us choose to play that game and not choose to play Excel unless we need to use it to solve a problem at work, for instance?
So I'm not a psychologist. I guess it's a very difficult topic. I know from one study, and actually know some people who are play testers. So they play games for money. One at EA, for example, DICE Battlefield, if that rings a bell to somebody. Yeah. So he's a play tester in Sweden for DICE. And the problem there is that also he was a fan of first-person shooters for a long time. Since he's working there for about a year, he switched over to some strategy games. So he's no longer playing first-person shooters. So there seems to be something involved, and if you have to do something, whatever it is, even if it is playing a game, so as he's now forced by his contract to play the game 4 hours a day or so, he completely lost interest and has no fun anymore in his previously most beloved genre. So he's not into first-person shooters anymore. So I guess that the key difference between games and challenges that you have in office programs, for example, is that you chose to overcome them. However this intrinsic decision process works, that's probably something that psychology people have to answer. But I guess the most fundamental thing is that you chose to overcome those challenges, whereas for the others who are forced or whatever, extrinsically motivated to overcome them. Did have I answered the question?
Yeah.
Perfect.
Daisy's got a question.
Oh yeah, sorry.
Yeah, hi, so there's this, again, I'm not a psychologist, I don't know much about psychology, but there's this concept called flow, which is used differently from game design and media studies flow. So it basically, if I can put it into different, less confusing terminology, it's about deep engagement with a thing. So in games we might call this immersion, but immersions kind of come to become how photorealistic your environment is in 3D space in games. Whereas I would argue that a game like Tetris is a better flow experience than many much more recent, much more graphically challenging games. So I don't think it was one of your features.
No, but I had flow here, so I plan to talk about it a bit.
Are you using it there in the same sense that I'm using it, as in?
Well, I was with this boring, so challenge versus skill of the player. Is that something else?
No, what I would say is I think you're probably drawing, because a lot of game learning stuff uses the same source. Like it's a author with a fantastic name, Sheikh sent me high here. Is I think how you pronounce his name. It's the most amazing combination of consonants and vowels. He's the psychologist who developed flow, and I think it has been adopted in game design as well. And it is from that same origin of an engaging task where you sort of lose time
yourself in it. So again, it's something that from the very limited amount I know, and it goes back to the previous question, is that flow experiences only work if you change them. If you get used to something, then it stops becoming an immersive flow-like, rewarding psychologically experience. But I don't know how long that takes, because you can play certain games for months and other games just for minutes.
So I would say, definitely the learning curve per player is unique. So I guess that there are certain actions where players adapt fast to it, and certain actions where it takes pretty long for players to adapt. So I guess that we can't really generalize that. I noticed that on myself, for example, when I played my first MMORPG, that was World of Warcraft, I was really amazed from this beautiful world. And so in every MMORPG that came ever since was only half the fun, because you immediately noticed, okay, that's this reward mechanism and I get this kind of skills there and whatever. So the discovery of the game world was decreased, even so it had at least the same complexity and the same beauty as World of Warcraft. World of Warcraft looked pretty bad as it came out. It was even an old-fashioned graphic style as it was released. But you learn from one game to another, so you already have certain expectations, and you need, I would say not even more challenging, but perhaps more complex challenges to be as immersed again. On the other hand, of course, there are games like Tetris, that I even will probably play later on the airport, that I still play today. Also, I spent like years in my house already playing it. So yeah, that's a rather difficult topic. I don't know definite answer. I don't know if there is a definite answer to that.
Just for the wider audience here today, just a couple of concepts around flow that are worth knowing about are the challenges an important one. And if something is too challenging, then it's too difficult and it's frustrating, and so you can't get sucked into flow. If it's many tasks, if they're too easy, they become boring, and that again stops users from getting really engaged and into the task because it's not challenging enough. And that's only one aspect of flow, it's not the whole thing. I think there are some unusual things about flow, and it's still, I think, something that's been debated as a concept. I think some of the origins of it was about heightened experience. I know a lot of the original suspects were like jazz musicians who would have great times on stage playing jazz and then go on to lead the most depressing lives. So it wasn't necessarily a recipe for happiness, but it was really about getting engaged in particular experiences, from those experiences. Can I actually ask, can you go back forward a slide from here where you actually listed, unfortunately you didn't show them all.
Oh,
they all overlap.
That's just what we talked about earlier, so it was not a presentation that we
I know, but I think it would be nice to just go through these more slowly, just so we can actually see what all these are, because these are really the key things that you're identifying for gamification as the useful things, and it'd be nice to see them side by side, just because I think this summarises, I think, a lot of what you were saying.
So that was the first thing that we discovered, the immediate reward mechanism, also measurable reward. Yeah, that's the initial stuff that we have. If you have a reward mechanism or a penalty mechanism that more or less, at least at that level, works the same, you should have it immediate, so that or easily associated with the action that caused it. And typically you do that by a small temporal distance between them. could perhaps do it with a larger distance and then some clearly identifiable link between action and reward, but typically just try to do them as immediate as possible and have them measurable. So give them some kind of points or coins or whatever, some measurable reward. That even goes so far as, and then we had the example yesterday when we talked that in some games we have an experience bar, and the experience bar fills pretty slowly on higher levels. What they do is they cut the experience bar in like 10% batches and then show a separate complete bar for each of the sections that you are in. So that even though you would kill this chicken or so, and it wouldn't give you any or this orc warrior, and it wouldn't give you any further experience on the main bar. It would give, but you wouldn't see it because it's less than a pixel. You still see a jump in the smaller subsection bar. So that's a nice trick that you do to that you really visualize it, make the reward measurable. What else do we have? Well, that's the action space. So that's something that goes wrong in so many Office programs. That a typical program does not show you the whole action space, so every action that you can do, mostly because they are a little complex. Also, I would argue that many games like StarCraft, for example, have a more complex action space than Excel, and they still manage to represent the action space a lot better. So try to represent the whole action space and make sure that if you represent it and you show all the actions to a player, make sure that you really show all the actions, that the player is really assured that this is the complete action space. It's very demotivating if you discover that later on, oh, there was an option better, but it was hidden in submenu 27. So really try to organize the software in your actions in a way that people, your users, see the whole action space and are sure that they see the whole action space. What else do we have? Yeah, that's the progress. So if you have progress over time, that was the pattern that we extracted from Diablo, for example, make it measurable. That's sometimes tricky, especially in Office programs, as if you have progress over time. Like in a program, say Visual Studio, for example. So we are programming something, and if I make progress in a certain submodule, it could be that it doesn't really change anything. It just might be just cleaning up code or so, and it's still progress. And that's relatively hard to represent that. Many real-life tasks come with relatively obvious measurements, but most of them don't. So make sure that you try to map whatever tasks there are in your money-making process or whatever underlying real-life process there is, and try to give them a measure so that you can measure development over time. Yeah.
How might you do that when we're talking about accessibility? And you talked about your blind friend.
Yeah.
Whether that's real or virtual. How might you do that?
Well, measuring, so you can measure progress, but you don't care.
Represent that for...
Yeah, represent this, yeah. You could say just compute versus a score, for example. You have a certain score, it climbs up. Now, I guess what you are heading is, how do I represent it? As if we said earlier that gamification should always be optional, and that leads to the difficult problem, again, if you have a two-dimensional space and we have our main task in the main, we just have a small piece of the application reserved for our gamification things where our high score is represented, that's fine for us, as we can only look down there in the bottom right corner if we need to. Now for a screen reader thing, we have to decide to either put it at the very beginning, then he's forced to, on whatever page he comes to first, skip this gamification thing, then it is no longer optional, or put it at the very end, and it's relatively hard to reach. So what you do there is, something that we, for example, experimented now with, is that you have that more or less in a separate piece. So it's, if you just read a page, it doesn't appear at all. But if you press a certain button, then it just reads the gamification thing. So it's more or less a toggle for show me my status, so to speak. That's something that you have to do. You have to come up with a bit of a more intuitively, at least for our intuition, more difficult way to navigate. But the problem is that our intuition is very wrong there. Our intuition is always based on two-dimensional information representation, or three-dimensional in the sake of my desk, for example. It's piling high. But if you really want to design accessibility and you are thinking about how do I represent that, get people who are actually doing it. So ask blind people. You can't do that intuitively. There are so many things that I intuitively would have thought that can't be the solution, that he say, wow, that's really good. So you really have to ask people. Intuition is something that can be misleading in that. Did it halfway answer the question?
Yeah.
Yeah, perfect. So anything else about measurable progress? Good. So what else do we have? Well, discovery. That's something, we did this in one class actually. We have a functional programming class, and we don't have to care about what that actually is. It's about a certain kind of programming languages. And what we had there is, we had a map that looks a bit like the Settlers of Catan, so all hexagonal pieces, and the tasks that you could do as a student, they were distributed among the map. So every tile was a programming task. And you could only do the neighboring tasks, so only you could only select tasks that are neighboring tasks that you already solved. And there were too many tasks to actually uncover the whole piece through a semester, except for one student who actually did that. Obviously not. But there were also in the corners that were everywhere hidden like small chests or so that rewarded you with a piece of a digital puzzle. And at the end of the semester we tried, we had a big wall, so at the beginning of every class we took, okay, which puzzle pieces were uncovered and we put them together. So the idea was that with the combined effort of the whole class, at the end of the semester we would have the complete puzzle done. And that was very interesting as the people really organized and say, okay, I am solving my solutions to the east, I am solving my solutions to the bottom west. It was this discovery aspect of games. We were just running around the fantasy world and trying to discover pieces. What we are currently doing, for example, is that's a project that I and a colleague are currently coding. That's where you have that's also for programming, for learning C#. That's based on a research where you have a drone in the orbit of Earth, and you program a small piece of AI that controls it, and then you launch it, and you have to fly around like black holes and supernovae and whatever you encounter in space. But you are not controlling it anymore, your AI program is controlling it. So you actually have to write an AI that's capable of reacting on whatever comes. And that's also this discovery aspect, because you can choose the route in which you go. So that's discovery, actually giving options to the player to discover new things. And you can do that in commercial games or classes, for example. I think that works probably better with educational things than with money-making processes. So I guess, it's just my gut feeling without scientific backup. My gut feeling is that this works better with if you want to teach people something than if you want to have a money-making process optimized, I'd say. Prove me wrong. Yeah, and then challenge. Like I said, challenge is the stuff that is in gamification typically not something that we have really under control, as it is imposed by our real-life problem. But we can try to design it and represent it and channel it in a way. And though there are a bunch of techniques in games on how to do that, that's where Flow, for example, jumps in, that you try to... Yeah, that's something that a bit of like systems that do source control do. If you try to solve the more simpler problems at first, and then you do this divide and conquer approach in game development, it's a bit about designing challenge. Divide and conquer is probably, so if you have a big problem that you can't really solve on its own, cut it into pieces and try to solve every piece on its own. That's a bit like that. So you have a big overwhelming challenge that would just drive you mad, cut it down so that each of the new challenges that you have now matches your current skill level. And you, in a company, you could do that per user. As some of your workers are more skilled in certain tasks and some of your workers are more skilled in other tasks, that could automatically adapt also. I think that's it, yeah. And of course, I think we talked about a few things earlier again, like, no, I think about everything is in there.